John,
Afternoon, sir.
what do you do?
There, no?
Uh, good, good. There are supposed to be two more of you. I think there are three of you who indicated an interest. Um, I'm just going to give a few more minutes um, for persons to join. Who are they again? You, Crosswell, and Kyle. So I don't know if you can reach out to them through the WhatsApp group to let them know that we are about to begin. Um, and then I'll explain to you how it is that we're going to be running the sessions. So do that now and then. I give you about 10 minutes to see if we can find them, and then I'll come back and just talk to you about some stuff.
All right, sir. Cool.
Mhm.
Good afternoon, sir. Good afternoon, everyone.
Hi, Kyle. How are you?
Yeah, I'm not bad at all, sir.
All right. So there's one more that should be joining. Yes. I'm gonna give a few minutes, and I don't- I think a few. I'll just give it a few more minutes to see if Russell will join, and then I explain how the classes will run.
Okay, sir.
All right. Dijon, Kyle, are you both there now?
Yes, sir.
Or still?
Yes,
All
sir.
right. Okay. So I don't think I'm going to wait on Crosswell any longer. This is now 26 past. All right. So I am I am true to my words, and my words, as I explained to you in class, that I will give you an opportunity to get through the calculus one this semester. Um, there were a number of you who should have been doing the course, but students say to me that they are going to be, well, not just me, because Mrs. Campbell came to me as well, that they're just going to forget about the calculus one until next school year and they'll just focus on the other courses. I tried swaying them not to do that because of the timetable issues. I will cross that river when I get there next year because if students don't turn up for my calculus one class, they're not going to be able to do the course. But that's a different kettle of fish. I'll cross that river when I get there. Um, so as I committed myself to the process, I'm still going to be meeting with you guys to get you prepared for the assessment. However, um, you all need to one You all need to pay for the course. You recognize you're not seeing the course on the link because it's going to be a special class, and this class is going to be called a self-paced course. Now, let me explain to you what a self-paced is. And I don't want anybody to say, Lord Jesus, sir, I can't do it. Last semester, like summer semester, I had 2 self-paced calculus 2 students that worked with me. We put in a couple sessions, not a full 4-hour sessions. I give them work to do. If there's a problem, they say, boy, sir, this is the situation. And we put in a little session here and a little session there. But most of the work is going to be done by you guys, having gone through the course before. You can access the recordings that I have. And every Saturday, I will meet in with you guys to see what is happening. We won't meet and have 4 hours or 5 hours of class. But I will assign you work. You will do the work. And if there are any difficulties, I will clear up those difficulties. Suffice it to say that those 2 students completed their course of study. And I know I saw one of them on the graduation list for next Thursday. I don't know what happened to the other one, if they had other courses outstanding, but I know both students got through with the calculus 2. I say this to say to you that if you put in the work, there is no way you won't get through with the calculus 1. And chances are you commit yourself fully to it and to the calculus 2. To Jean, that is, because I know Kyle is doing it. You will be able to catch up your other students. And Kyle, you'll be in a better position because I don't know what will happen, who to tell. I don't know if summer there will be a calculus 2 session where it is that we can join the calculus 2 session, who to tell, not sure yet. But I just want to see if you guys are still committed to doing this as a self-paced session. And before we get the go ahead, there are supposed to be 3 of you. So if 2 of you agree, then it will go. If one of you don't agree with it, I'll have to wait on Crosswell to find out his position. And if he says yes and one of you say yes, then I'll run it. If both of you say no, the majority will rule, and then we just call off the class. So let me know what it is that you are doing.
Yeah, I have no problem with it, sir. That's a yes for me.
Okay.
Sir, fully committed, sir. To add to that, I actually paid
Good.
for both calculus 1 and 2 yesterday. So yeah.
Great. Say no more. Say no more. So I know
Question.
based on the fact that you go ahead.
I was asking, sir, how do
Go
I
ahead.
go about selecting? I was asking, how do I go about selecting and paying for it?
All right. So the selection is the course is not yet added. So that's why I'm not seeing a link out. And that's why I had to be round robining and getting Carno and sending you emails and so forth, because I know now that I know that there are 2 of you who are interested in the self-pace. I can then now say to Mrs. Campbell that I'm going to send her an email now to say that I have the pair of you. I'm not hearing from Crosswell, but I can say to her that I have a pair of you interested in doing the self-paced calculus 1. Matter of fact, I have completed my submission. Well, I have completed 3 or 4 questions for my submission for calculus 2. And as it is just now, I have pencil in hand to do the last question so that on Monday I can submit Excelsior's contribution to the calculus 2 exam. And over this weekend, now that I know you guys are committed, I will be doing a calculus 1 exam paper. All right. So I will say to Mrs. Campbell, matter of fact, I want to send her the email now. I'll just wait until I'm submitting the exam papers. Then I'll just send her the email to say, yo, here's a paper. I have these 2 students who are interested. Hopefully, Coswell will join on. All right. So let me tell you how the self-paced works. You have my recordings. You have all the recordings. You have access to my YouTube channel. I will direct you. Forgive me here. I am at the stadium for a function, and I'm locked up in the car and this music is blaring, but anyhow. So this is how it works. I will go through some stuff. I will give you work to do. You are going to be going, and incidentally, Educasoft should have been up yesterday, Friday, but as I said in class one day this week, the person who is supposed to be giving the go-ahead internally, both persons in the office fell ill, and I am yet to hear from them. So I was really hoping that it would have been fully up yesterday as I was promised, so that I could you know get you guys up and running. But I'm gonna follow through in the coming week to see exactly what is happening. But for now, one of the things that I want to focus on is stationary point. I want to focus on stationary point today, and what I want to do is to give them on stationary point. Um, you should remember how to do stationary point. I will give you an opportunity to start. If it is that you don't have an idea or don't remember how it is done, I will go through a question with you on stationary point and then give you a few questions to do. And then you're going to work on stationary point for me for this week. Remember, stationary point is almost a full question on the exam paper. And almost a full question means 30 marks. All right. So if you can get your stationary points out of the way, you are good to go. Work with me. Trust me on this. All right. So that's where I'm going to start. And there's a reason I'm not going to start with the limits. I'm not start with the limits, and I'm going to tell you why. Most of you understand limits. I'm at the papers and I saw what I saw. Most of you, most of you understand the limits, and I'm going to do the limits sometime later because I know you guys understand that. So stationary point is where we're going to start. Agreed?
Yes, sir.
Yes, sir. Sorry, I did ask if you could reshare the link to the video then, channel 1 and 2.
Um, no man, go to the YouTube channel. It is. You don't have it's in the description. You don't have it in the description. Look in the Calto group. You will see the link, man, for the YouTube channel. It's there, man.
Okay.
Check and let me know now, please. And incidentally, Dijon, all the Calculus 2 recordings for this semester have been uploaded. So please check. Kyle, do you have the link for the session?
Sir, subscribe to your channel so I have it.
Okay. Can you drop the link in the? All right. Let me see if I can. Let me get the link.
I
I'll get the
can
link.
try and get it, sir. Hold on. I
All
can
right.
try and get it.
Yeah, because I'm looking and I'm not seeing it. What your name on it again, sir? Mark Shan, just your name?
I think so. Some 588 something. I can't remember it
Okay,
offhand at
sir.
all.
Look at my find it.
Say it again.
Yeah, look at my find it. Mark Shan 585088.
Yeah, man. Some 58 something. Yeah. All right. Good. I'm happy they found it. I need to. I sent an advisory. I'm not sure if Lacarno sent it, but I shared an advisory today with you all about the system going to be locking out at the end of this month. I think like the 28th or something like so. Please ensure that your registration is up to date. I don't want what happened to you guys last semester happen to you again.
Yes, sir.
Question, sir, for the recordings, how you know like the order? Because I'm not really see like date or
Yeah. When I get the recordings, sometimes the recordings don't come to me immediately after. And so for me to go and look at the dates and so forth and so on, that is going to be way too much work for me. In terms of putting that lesson 1, lesson 2, so forth and so on. What I try to do is to upload them in, not try, what I did is to upload them in order. So the first recording should be the one on the, was it the 13th of January, I think it was. So I uploaded them in order. But yes, I apologize. There's no way I can go and put lesson 1, lesson 2, or even to say lesson on A or B. That's way too much on my path.
okay, so
So
it's
I just
saying that the most recent recordings are the most recent class.
no man. So what one of the things that I can tell you is that so how you'd identify the recordings for this semester would be Math 4702, Calculus 2, Semester 2, 2025. So once it's semester 2, 2025, you know that this is this semester's math class. So that's how I label them.
Yeah, man, I
So
understand that, but I'm saying in terms of like the classes, like
the
the
lessons,
most, yeah, the right, not the lessons itself, but the class, the entire recording itself. Like the first recording or the first class that we had, I would have to scroll down to find that, right? And the one that
right,
was held probably last week would be at the top.
right, right,
Okay, understood, understood.
right. So so the first calculus 2 September, I mean semester 2, 2025 will be the first class, and the next one will be the second class, so forth and so on. Get it?
Understood.
All right, cool, cool. Let me know when I can begin, please.
I'm already, sir.
All right, cool. Uh,
Just as a refresher, so I prefer, you go through one and then do one
oh
after.
yeah. Yeah, man, that's what I plan to do. All right, so I am not worried about the differentiation with either of you either, because I mean we know that we have to differentiate in calculus too. So the differentiation is not what I'm worried about at this point in time, if I were to be honest. Um, oh crap, I opened the wrong document and then also I opened it and I never. So the differentiation, I know you know. What I'm concerned about is the application now of the differentiation to go through the stationary points. And I am going to find me a question that I have just found. And I'm going to be sharing that just now with you.
Sir, you don't get back like exam papers,
What do you mean by exam papers?
like like even calculus one that we did and your mark, like it's impossible for us to get that back. Like to just go through it and see where we go wrong and can use it as
The exam
practice.
paper,
Yeah, from last semester.
and let me just get you correct. You're saying the exam paper itself?
No, as in our exam paper, we actually did what we write. Or the booklet,
That's what
I
I'm,
should
that's
say.
what, that's what I'm asking you. Your calculus one exam paper?
Yeah, yeah.
No, I am not. I'm not allowed to. I mean, I don't have those papers. The papers are marked and sent back to exams. So the most I can do is see if I can get a copy of the exam paper itself, and you just work with that. But in terms of the marked paper, I have no access to it.
You know why they do that, sir?
Huh?
Do you know why that is the practice?
Um, it's not just Excel, so it's international. Um, the truth is the exam papers now become a legal document, and that legal document has to be kept within the institution for 7 years. So 6 years after you've left Excelsior Community College, we still have copies of your exam papers because
Okay.
it becomes a legal document. Because at any point in time, even at any point in time, okay, so your degree has to be ratified. Your degree has to be ratified. So even when those students who are on the graduation list to graduate come next week Thursday, if something if the institution were to find something that goes awry with the students' stuff, we will need to be able to pull those exam papers and send off to the external moderators. And then, even though the student graduated, if, say, for example, they recognize that the student didn't do a one course, and even though the student would have graduated, the student will not get the degree because the ratification process has to go. So the students must be ratified. Now, what we have to do is to pull those papers, and because it can become a legal issue, we will then have to pull those exam papers, and those exam papers will have to go to court, so forth and so on. So we can't give students those papers, and we can't even copy those papers and give to students because they no longer become your paper. It becomes a property of the institution. After that time, the papers are shredded and, of course, destroyed to make room for the other set of students. I don't know if that explains it.
Yeah, man, sir. Okay, I know.
Yeah. I'm happy you asked the question because I had a situation recently where a very disgruntled student apparently called CCCJ on a matter, and that was somebody has called me to say to me, "Sir XYZ, this is what the student did, so forth and so on." And to be honest, it was last week. It wasn't last week Saturday, it was week before last Saturday. Last week Saturday or somewhere else. It was week before last Saturday. The student sent me an email, and I didn't let the student know that I know that the student called CCCJ. And the week before Saturday, I was working with the student, and the student was saying, "Oh, sir, and this is not working." I said, "It is working, but this is a situation, so forth and so on." "Oh, I didn't know." I said, "That's why you need to come to the source." So you can't, if something, for example, Dijon, you're saying, "Why can't I get my exam paper?" Etc. is just awful because you do the exam, I can't get back the exam paper. No, when I explain what it is that I explain, that it's not just Excelsior, it is an international rule that the papers are kept for a certain period of time. In Jamaica, it is kept for 7 years. Then, XYZ, so forth and so on. It becomes a legal document. So it's after I've explained to the student, "Oh, sir, I didn't know." And, I just said, when next you have an issue before you go somewhere else, come to the source. Come to the source, talk to the source so that you can get the information clarified before you go out there and bomb blast your own institution, right? Somebody who don't know may say, "Me not go excess here. Yeah, man, I saw them stay them too wicked," but somebody who knows that, no, don't say that. This is how the rule goes. So I congratulate you for asking the question at point. All right, so I'm sharing the screen, and we are looking at stationary point. And in particular, I'm looking at f of x equals 2x cubed plus 3x squared minus 12x. Let me just explain something here. I would prefer if you go through the other sessions, because these recordings may not be full length, because, like, for example, I won't stay after I've explained this to you. I will then give you work that you can do on your own, right? This is how the self-paced works. So the recordings may not be the full length recording that you're accustomed to. That's why I'm sending you to the YouTube channel, so you can go on and sort out
Understood, sir.
those. Sorry, say it again.
So we're saying that I understand what you're saying.
Sorry, Kyle, I'm not hearing you.
Cool.
I was saying, sir, that I understand.
Oh, yeah. You were very muffled a while ago. Get you. All right. So this is it, though. So I'm just going to ask you to come close to the screen. Give me about 15 continuous attention, 15 minutes of continuous attention, and then we can just go through this. You ask me the questions, and then we just go through the stuff. So you have a function. Remember, I want you to differentiate the function. So write for me. First step, differentiate. No matter of fact. Yeah, write it. First step, differentiate the function. First step is to differentiate the function. All right. So you have the first step to differentiate the function. Let us differentiate this function.
And
2x
that
cubed
mark
plus
beside the F means differentiation, right?
this mark here, so?
No, the little mark, the little like
This,
thing. Yeah, that.
right. F dash of x is the first differential, yes. That is representing the
Okay.
first differential. Very good. So we first need to differentiate the function. You're given f of x, so it now becomes f dash of x. F dash of x is the differential of f of x. Now 2x cubed, when I differentiate 2x cubed, what do I get? Say 6x squared, no, man.
6x squared.
Yeah, man, 6x squared. And when I differentiate 3x squared, I'm going to get 6x. And when I differentiate negative 12x, I'm going to get negative 12. You get 1 mark for just doing that. That's your first mark in differentiating a function. I give you another mark for recognizing that for critical points, dy by dx equals 0. So the next step is that you have to set f of x equals 0. If you write this on paper, you get 1 more mark. For critical points, f dash of x is equal to 0. So you're going to differentiate the function, and then you're going to set the differential equals 0. That's another mark. So I'm going to set this 6x squared plus 6x minus 12 to be equal to 0. I'm setting that equals 0. All right.
So, sir,
Having said, go ahead.
if you do what you just said, where you got 6x squared plus 6x minus 12 equals 0, you still get the mark for that?
Yeah, man. Yeah.
So you don't necessarily have to do the second one where you have the differential of x equals
So
0.
if you wrote this line like this here, I would give you 1 mark for this first piece here for the correct differential, and then I give you 1 mark to say that it's equal to 0.
Okay, cool.
But you have to label it though. You have to go label this as f dash of x equals all of this. So if you just write it all like this, Dijon, I'll give you both marks. But in teaching, I have to tell you why it is that we're doing it. Why we setting it equals to 0? Because I'm finding the critical points. The critical points occur when the differential is equal to 0. The turning point is equal to 0. It only occurs when the turning point is equal to 0. The turning point is the same thing as a critical point, the same thing as a stationary point. It only occurs when dy by dx is equal to 0, or f dash of x equals 0. All right, now, this is one of the things that we can do. Because 6 is common throughout this equation, 6x squared plus 6x minus 12, I can divide throughout by 6. So why are you dividing throughout by 6? I'm dividing throughout by 6 so that my equation now becomes easier to work with. My equation becomes easier to work with. What do you mean easier, sir? Look at this. Now I don't have to say 6 times 12 is 72, and then find factors of 72. When added will give me negative 72, but when multiplied rather give me negative 72, but when added will give me a positive 6. Dividing through by 6, I now have x squared plus x minus 2. When I multiply the coefficient of x squared, which is 1, by the constant, which is negative 2, I can simply say I need two numbers. And multiply together will give me negative 2, but when added will give me a positive 1. And those two numbers will be positive 2 and negative 1. And then when I do the factorization that I'm going to show you, because interesting. Oh, for crying out loud. I knew this was going to happen. I knew. Let me tell you now. If only I follow my mind enough. I was using the stylus yesterday. The stylus was on the bed. And I took up the stylus and put it in my pencil box. And I heard a voice said, don't put it in the pencil box because you may leave your pencil box. Put it in the bag. And I said, sure, the bag is too far. See? I have everything away from the stylus. So I can't even write on screen now. Cha. If only I just followed my mind.
Sir, just one more time. You can explain how you get the
Two
plus 2 and the
factors.
minus 1 again.
Yeah, man. That's exactly what I wanted to write down. That's exactly what I wanted to write because I know that part of it is tricky, but your teacher didn't listen to his inner voice. Aye. I knew I was supposed to put it in the stuff, I just didn't listen to my inner voice that says, yo, brother, do this. Aye. I'm going to be damn down, but I'm just making a last ditch look to see if all right. So unfortunately, I can't write. I didn't walk with the promise, but I'll explain it. So what I'm saying to you is, I want you to write for me, please. You write for me. You write 6x squared plus 6x minus 12 equals 0. Then you're going to divide throughout by 6. You're dividing throughout by 6. So each
Sir,
term.
can start over again?
A lecturer is having a class now and is having a challenge. Hold on. 1 minute purpose. I'm not seeing the students of class. Class should begin at 1 and go through to 5.
U.S. global influence and diplomatic reach. Trump and Musk are shutting down U.S. aid. Here's what's happening. U.S. aid operating in over 100 countries. Funds humanitarian aid, health, and economic.
I don't understand at all because women's here, guys. I don't have this number. Right. I don't know what is happening because Performing Arts called me yesterday to say that they have a list of students for the class. So I was just calling the head of Performing Arts to find out where the students are. So just hang on a little while longer for me, please. All right, thank you, miss. Appreciate it here. Cool. Let's see if this will answer the call again. No. Hello, my neighbor. How you doing? I hope you're not in church. Yeah, you're not in church? Okay. Oh no, I hope you get better. All right. So the FCM1 lecturer just sent me a message. I'm actually in a session now. And she sent me a message to say that she's only seen one student in the class. How many students you were talking about to me last night? Mhm. All right. So you saw this morning I got up pretty early. I think I may have sent you the link about either 4 o'clock or 5 o'clock this morning. You saw the link? And you sent it up to the students? No man, the FCM2 would have been finished already, because that goes from right. All right, let me tell you the difficulty I'm having with this because last week I went into the session and there were only 2 students. And this week now she's saying it for FCM1. And this week now, huh? No. In general, because I mean the FCM1 is for those, and right, it's college wide. Anybody who needs to do FCM1, good. So it's not just the performing arts students. So last week I had 2 students, and I think those students are from business. And the lecturer just messaged me a while ago to say that she's only seen one. So if the students don't come out this week, I'm gonna call the class off. Because so next week will be the 3rd week, and if the students don't come up by today this week, right? So see if we can run robin with them and let them join the class now, because I did ask her to stay on a while longer. No problem. All right, forgive me, your students. You see, your teacher don't get no rest. It is what it is. But I do this because not for the likes, it's because I really want students to make it. All right. So I was asking you to write something for me. So you wrote 6x squared plus 6x minus 12 equals 0.
Yes, sir.
All right. Right from now, dividing through throughout by 6. Dividing throughout by 6. I don't know how that's to write on the screen without it. I wonder if that stylus would write on it. These man, right, divided through by 6, and then now you're going to end up writing x squared plus x minus 2 equals 0. X squared plus x minus 2 equals 0. Are you with me?
Yes, sir.
All right, good. Now I want you to write this. Multiply the coefficient of x squared by the constant. Multiply the coefficient of x squared by the constant. Multiply the coefficient of x squared by the constant.
Sir, I'm rusty, so I have to remind what all of that mean again.
The coefficient of x squared is a number in front of x squared. So make that notation. The coefficient of x squared is a number in front of x squared. So what number is in front of x squared?
6.
6.
No, man. You remember I tell us it must divide through by 6 already? So we have now x squared plus x minus 2 equals 0 down.
Oh, 1.
1. Very good. Kylie, see that?
Yes, sir. Yes, sir.
Yeah,
I'll be
man.
glad to write it.
Right. So you're going to have that sort of imaginary 1 in front of x squared. So yes, you're correct. So it's going to be 1. What is a constant? What's a constant term?
That would be the number behind x squared.
That's the number that stands alone, that don't have no x to it, that you're not seeing any x to it. What number is that?
6.
No.
2.
What kind of 2?
-2.
Negative 2. Does Johnny seen that?
Yes, sir.
Good. So the coefficient, so in my trinomial, I have 3 things in my trinomial. The 3 things that I have in my trinomial are the term in x squared, the term in x, and the constant term. The constant term is a term that you're not seeing an x term to it. There's an x term, but you're not seeing it. You're not seeing it. All right. So it is x squared plus x minus 2. So the number in front of x squared is called the coefficient of x squared. The number in front of x squared is called the coefficient of x squared, and that number is 1. The number in front of x is called the coefficient of x. What number is in front of x?
1.
Very good. And that is the coefficient of x. The constant term now is
-2.
negative 2. All right. So the method is to multiply the coefficient of x squared by the constant. Multiply the coefficient of x squared by the constant. The coefficient of x squared in this case is 1. 1 times -2 is -2. I want to write that, I want to write 1 times -2 is -2 because I want, when you're looking back, you can see what it is that we did. 1 times -2 is -2. Write this now. I need 2 numbers I need two numbers. I need two numbers. When multiplied gives -2, I need two numbers. When multiplied gives -2, but when added gives +1. I need two numbers when multiplied together gives -2, but when added gives +1. And then you can say to yourself, say, -2 is the product that you get up top, and the +1 is the middle term. So -2 will be the product of the coefficient by the constant, and +1 is going to be the middle term. So you need two numbers. When multiplied together will give you -2, the product, but when added will give you +1, the middle term. Supposed to give you the middle term. So the two numbers we're thinking of there would be +2 and -1. Two numbers are +2 and -1. How do we get that? +2 times -1 is -2. It fits the first condition. Does it fit the second condition? Let us check. When we're adding +2 to -1, +2 minus 1 equals
One.
+1. And +1 is a middle term. So they fit both conditionalities. It can't just be one condition. It has to be both conditions that it fits. If it only fit one condition, it can't use it. If it fit only one condition, it can't use it. It must fit both conditions. Both conditions must fit. So what you're doing now, you're rewriting. So write for me, rewriting. Then you're going to write x squared plus 2x minus x minus 2 equals 0. Then you're going to group. Write the word grouping for me. Then we're going to open parentheses. And then we're going to write x squared plus 2x in one bracket. So we're going to open bracket, x squared plus 2x, close bracket. You're going to put a negative sign. And after you put a negative sign, you're going to open another bracket. And you're going to write x minus 2. All right. Read what you have for me, please, that last line.
So rewrite open parentheses x plus 2 x minus 1 equals 0.
No. X squared
Oh, x squared.
plus 2x,
Mm-hmm.
close bracket.
Yes, sir.
Have a minus sign there.
Yes.
Then open bracket. And then you write
Mm-hmm.
x minus 2, and then the close bracket equals 0. But I want you to look at the signs. In the first parenthesis, you have a positive sign on. Talk to me.
Yes, sir.
And in the second parenthesis, I have a negative sign on.
Yes, sir.
All right. Now, both signs in the bracket supposed to be the same. So you see, whenever you have a negative sign outside there, so in between the two parentheses, you have to flip the sign of the last one. So where you have the x minus 2, it's really supposed to become x plus 2. And I'm going to check it and show you. We're going to check it to make sure that we're not doing anything illegal. That negative sign that is in between the two parentheses is really -1. When I multiply, I'm distributing that negative sign in the parentheses. So -1 times x gives me a negative x, don't?
Yes, sir.
Look up the line before and see if you see the negative x up there.
Oh, yes, sir. See that.
Good. And also, -1 times a +2 gives me a -2. Look up top and see if you see the -2 up here.
Yes, sir.
All right, good. So that's what we do. That's what we do. We once there is a make a notation, once there's a negative sign between the two parentheses, you have to flip the last sign. You have to flip the last sign. You have to flip the last sign. Now, you're going to be factorizing now. What is common between x squared and 2x?
X.
Factor out the x for me, please. So you can write x and then you open your parentheses. And when I take out x from x squared, what do I have left?
X plus 2.
Okay.
Excellent, Dijon. Very good. X plus 2. Very nice. Very nice. I heard that, Kyle. Very nice. And then you're going to close the parentheses. And then you're going to put back the negative sign. And you recognize that you have that x plus 2 over in the second parenthesis, don't?
Yes, sir.
So you're going to put your -1 right there, and then just write back x plus 2 equals 0. X plus 2 close bracket equals 0. And then now what is common between x times x plus 2 and -1 times x plus 2? What is common between x times x plus 2 and -1 times x plus 2? Look at what you have on paper. What is common?
X is common between the two of them.
The x plus 2.
X plus 2 is common between the two of them.
Right. So you're going to take out the x plus 2 and then tell me what you have left.
X minus 1.
X minus 1 equals 0. I have the x minus 1 equals 0, and then that's what it is that you have. All right? And then now you can pick up from where I have right here, so on the stuff. X plus 2 times x minus 1. So the middle piece here that is missing is what it is that I just asked you to write. Look at it and tell me that you understand, please. Very important.
Yes, sir. Understand.
Good job. DJ, what you say?
Yeah, understand, but let's try to get it in my head. Just try to get it in my head. So you say, you just need two numbers that when you multiply them, it gives what the one with the power.
Mm-hmm.
You add them, it gives the one without the power.
In the middle term. Call it the middle term.
The middle term.
Right, right. And you'll be correct. But I want you to take a few minutes just to look at it and see if any questions come up. You can go ahead and ask me those questions. I'll be more than happy to answer those questions for you. It is important that you you understand this pop up before we leave, because we're passing calculus 1 and calculus 2 this semester. So I don't want you to formulate any hiccups, and you can't get an A for calculus 1. You get an A for, and that's the beauty about it. The college don't penalize you. So you do over this course, now and get an A, your GPA gone up. All right, so try and get an A for the course, and improve your overall GPA performance.
That's another question I did want to ask, sir. Will I get coursework and access to Canvas and all
Yep.
that stuff at the same
Yeah,
place?
man. I did make mention of the Edico stuff already. But yes, you can get coursework again, and you can get mid semester. Remember, it's a redo of the course, you know. It's a redo of the course, but it's just that we're using a self-paced methodology. So I will be there to guide you, like I am doing now. So for example, I may leave the session at 2:30 and say, use the rest of the time, guys, to go through the stuff. Yours is going to be the responsibility that, sir, give me 2 questions. I'm going to do the 2 questions and make sure I understand it, and just go watch 2 more videos and then call it a day. Right? So you will take the responsibility to doing the work. My responsibility is to make sure that I give you work to do and I guide you through the stuff. Now, I've already created a WhatsApp link, an email chain with the 3 of you. You send me an email and you can reply to all, or if you want to send me something direct, you just send me direct using the same chain. I prefer if you just use the same link, so at least I just go to one place. You can reply to all, I can just reply to me using the same link, or the chain email thread. And send me a message if you're having a difficulty. If I believe that, okay, maybe this is something that the other students can benefit from, I may say to you, all right, here the plan, guys. We can't wait until Saturday to deal with this. There's a misconception somewhere. When you can give me half an hour, let me just clear it up. And then, because there's also 2 of you, maybe this time now we'll just do a little Google Meet, instead of the Zoom, because the Zoom get a couple for me to set up. We'll just do like a Google Meet, something where we can share a screen or 2, and we talk about it and just leave you there. So this is what the self-pace is. Self-pace is me guiding you as you prepare for your exam. As you prepare for the course, I am going to be here to guide you. So what is important is that you're doing your work, and Kyle and Dijon is also 2 of you work together. What was a success for Calculus 2 self-pace in the summer is that both ladies knew each other. When one lady came to class and the other lady not there, the one lady said, sir, we could just have the class here. Me go try my best to understand it, so me can go through and explain it to the other student. They say, all right, do you think? Because it have to do. And they came and they write their exam face to face. I mark their papers and then pass the course. So the 2 of them again link up with each other and go through the stuff, and you're not having a problem, either plan. We are available at this time. Me go check sir and see if sir are available. And I'll find the time. I'll find the time because I really want you guys to do it. So I'll find the time. So this is how self-paced going work. It is very useful so that you don't have this course carrying over into your 4th year. I'm giving you an opportunity to do it. And here we plan. Please appreciate what it is that I'm doing. I'm going to tell you why. I did 2 self-paced last semester. Calculus 2 on my next course. Can't remember which course it is. And I promised myself that I will not do the self-paced again because of the difficulty I was having with the students. Peer excuse, can't come class, peer excuse, right? And I said I'm not doing it again, but because I am committed to seeing you guys doing what it is that you're doing, I went against my own words. So the pair of you or the 3 of you will determine whether or not it's something that I will continue doing, please. I don't want to waste my Saturday and to waste your time. All right. So, Dijon, look at it now again and tell me if you can follow me now where I got this x plus 2 times x minus 1 from.
Yeah, yeah. Yes, yes, sir. Yeah.
And Kyle, how you stay?
It's all coming back, sir. I don't understand what you're saying.
Very nice. Very nice. And that is the spirit. I want it to all come back so you can see what is happening there. Very nice. All right, let's continue now. I'm going to continue from what I have on screen here now. So because I have x plus 2 times x minus 1 um, equals 0, either x plus 2 equals 0 or x minus 1 equals 0 or both of them equal 0. So therefore, if x plus 2 is equal to 0, I need to find the value that makes x plus 2 equals 0. I mean, I transpose, I'm going to get x equals negative 2. Look at that and tell me from your notes in your book if you can see that x is equal to negative 2.
Yes, sir.
Good job. Kai?
Yes, sir. I was speaking, but the mic was on mute.
Yeah, man, don't worry. It happened to me enough time. Great. And you can also see that x is equal to negative and positive 1.
Yes, sir.
All right. I want you to note these are my critical values, not my critical points. They are my critical values. Let me tell you what one student did in the exam. I was so annoyed. I hope it's none of you too. The student did the factorization and got the factorization right and reached there, so and the critical point is x equal 2, x equal 1, and move on to the other question.
Sir, that was me.
Oh, that was you?
Yes, sir.
All right. Sorry to talk your business. I was annoyed at you then, Kyle. So you only got 4 out of I think the 20 for that question. And I'm saying, look how the student is going on pretty nicely. I was like, oh my goodness, I was livid when I saw it. So now that you made the mistake, then I know you won't make the mistake again. So those are the critical values. What I want you to do, the pair of you, I'm not going to project it. What I want the pair of you to do now. You see, in this function, it says put x equals negative 2 into the function. I notice that this into f of x. I notice that f of x is the original function that is given. 2x cubed plus 3x squared minus 12x. So I want you to substitute that for me and tell me what f of x value you get out. Do that for me now and tell me what answer you get out from that.
Sir, what's the other name for critical values?
Stationary point or turning
Stationary
point
point. Yeah. All right.
or turning point. I'm waiting on you to tell me. I don't want to just do the things by myself. I want you to be part of this learning experience. Let me know if you get the stuff, you know. I want to know if you get the stuff. So you can drop it in the chat or send it to me privately in the chat or to everyone. It doesn't matter to me. Send it in the chat. And then when you finish the x equals 1, I mean the x equals -2, I want you to try the x equals 1 and see what you get.
Sir, I tried, sir, but I'm not sure if I'm right.
What you got for x equals -2?
20.
Huh?
20?
Do Johnny do it? Dejan gone?
Sir, I'm sending it in the chat.
Yes, sir. Just send it in our chat. So we get -228 for -2, and for 1 is not 2, 1 and -7.
You said one. It's positive. Send me have here though. What is supposed to be?
Sir, I got the second part, sir. That's the first one I didn't get the same as him.
So you get 2 and 7 2 for the second part?
No, sir. 1 and -7.
Dejan, what is it? Supposed to be 1 and -7?
That's what I got, sir. 1 and -7.
All right. Okay. You made a mistake with the calculation for the first one, Dejan. Very good, Kyle. Look at it, Dejan, and pick up the error, please. Let me know if you get it, Dejan.
Sir, but couldn't I call negative -2 squared is -4, right?
Mm-hmm.
And then times that by 3, isn't that -12?
No, because -2 squares is +4.
But that not that's first, so -2 squared is not -4.
No, it's not.
Okay.
If you're using a FX82 calculator, if you only put in -2 and then square it, is when you give a -4.
Yeah, that's what
Because,
I did,
right,
and that's
because
what I get.
it is not recognizing the negative sign in front of it. In order for you to get it to recognize the negative sign in front of it, do this for me. Open your parentheses, then put a -2, then close the parentheses, then square it, and tell me what you get for the answer. Put a -2 into parentheses and then square it and tell me you
Yeah, I
get a
got
positive.
4.
Oh, all right.
Yeah.
So always, whenever you are working with negative signs, always put them in parentheses, please.
All right, sir.
Good, good. All right. So I can continue now then.
Let me just get the answer quick.
Sure.
All right, sir.
Good job. All right. So my stationary points then. My stationary points are -2, 20 and 1, -7. Now, you know why I'm taking my time with this? Because if you get up here so wrong, the rest of the something wrong. if you get up here so wrong, everything is wrong. So you have to take your time and do the question to get up here so correct. Very important. All right, let's go. So now we need to investigate the change in f dash of x in the derivative. So this part of the question will say to you, classify the critical points. It will say to you, classify the critical points. And in order for you to classify the critical points, you're going to find the second derivative. You're going to find the second derivative. It means that you're going to differentiate the first derivative one more time to get the second derivative. So find the second derivative for me, please. And if the first derivative is 6x squared plus 6x minus 12, when I differentiate this one more time, I'm going to get 12x plus 6. 2 6 is 12x plus 6. I'm going to get 12x plus 6 right here.
What you're finding again, sir, it's the nature of the curve, right?
You're classifying the nature of the critical point. So the question will say, classify the nature of the critical points. Pretty much what it is that you want to do is to see whether or not the critical point is a maximum point or a minimum point. So you're classifying the nature of the critical point. All right. And then if you're looking at the critical point 1,7, no, let us look at the critical point first, -2,20. Now in this second derivative, I don't have any y value. I just have f of x is equals to 12x plus 6. So since there's no y value, I'm going to go ahead and substitute my x to be -2. Anywhere in the second derivative, go ahead.
Sir, not to jump the gun, sir, but for me,
Hello,
by
sir.
the
Hello, sir. I just managed to get back internet.
Okay, Crosser, good. Yes, Dijon, you're saying no?
sir, I would say not to jump the gun, sir, but by looking at it, sir, is the local maximum -2?
No, it is -18. Yeah. The local maximum is -2. Yeah.
And the local minimum is 1.
And the local minimum is going to be a +1. Yes, you're correct.
All right, sir.
I'm assuming this has to do with a function on a graph, right? Right, sir?
You're going to end up putting it on a graph paper, yes. Not on a graph paper, you're going to sketch it.
No, because I saw the terms maximum and minimum, and I saw a function. That's what I'm asking.
Yeah, so you're going to sketch, not put it on a graph, but you're going to sketch a curve. All right, so let's continue. So now, what you're going to have is this -2, I'm going to substitute into 12x plus 6. So 12 times -2 is -24, and I'm adding 6 to it. So -24 plus 6 is going to give me -18. Now, the fact of the matter is, because the function evaluates to a negative value, I'm going to have a local maximum. So my critical point at -2,20 is going to be a local maximum. It means that that graph is going to turn downwards. So that tells me that my graph will turn downwards. All right. Similarly, I'm going to have the given function, and what I'm going to be doing is substitute the other critical value, or critical point rather, into that f double dash of x. So anywhere in f double dash of x I see x, I'm going to put positive 1. See there? 12 times 1 is 12, and 12 plus 6 is positive 18. Now, because it is a positive number, I have a local minimum, and that minimum value turns upwards. So the local minimum turns upwards. The local maximum turns downwards. So I've classified my critical points. I know which one of them is maximum now, and I know which one of them is minimum. Any questions?
None from me, sir.
Okay. Kyle?
Very good.
Okay. Crosswell?
I just got it. I don't know the full context, sir.
Okay. All right. So having gotten my critical point, and having classified my critical points as local maximum, local minimum, I now need to find the point of inflection, my y-intercept. So the question would say to you, determine the y-intercept. Now the y-intercept is found when x equals 0. Make that notation for me, please. The y-intercept is found when x is equal to 0. The y-intercept is found when x is equal to 0. When do I find the x-intercept?
Repeat.
When do I find the x-intercept? The x-intercept is found when what?
When the y value is 0, sir.
Yes, thanks. So the y-intercept is found when x is equal to 0, and the x-intercept is found when the y value is equal to 0. So when whichever intercept you're finding, it is the opposite variable that is going to be equal to 0, not the same variable. So I can't find the y-intercept and then put y equals 0. No. It's so finding the y-intercept, that means x equals 0. And find the x-intercept, it means that y equals 0. Are you with me?
I'm
Yes, sir.
trying to follow the logic, sir. Just as an aside, sir.
Mm-hmm.
Maximum values tend towards the negative, right?
Yeah.
Okay. That's what I wanted to confirm.
Are you okay so far?
Hmm. Um, not to interrupt you so late into your session, but what have you done so far, sir?
Just this.
Oh, just
We're
this?
waiting on you, so we started late. Yeah. We're waiting on you, so we started late.
Oh, sorry, sorry, sir.
So to find the y-intercept, I'm going to put x equals 0. Anywhere in the function I see x, I put 0. So that's 2 times 0 cubed plus 3 times 0 squared minus 12 times 0. And I'm going to get x equals 0. I'm going to get x equals 0. All right. And then the point of inflection now, which is the last part of what we're doing. The point of inflection is when you use a second derivative, set it equals to 0, solve for x. Write for me, please. Use a second derivative. Use a second derivative. Set it equals to 0. Solve for x.
Use second derivative, equal it to 0, solve for x. Let me see the formula. 6x squared plus 6x minus.
No, the second derivative is going to be 12x plus 6. 6x squared plus 6x minus 12 is the first derivative. So you can't use that. If you use the first derivative, you're finding the critical points. We've already done that. So if we use the second derivative now to go to do something else. So it's a 12x plus 6 that you have to use.
Okay.
All right? Did you all get that a half, negative a half?
Yes, sir.
Okay, good job. What about the rest of the two, the other two?
I found a negative half as well.
Good. Substitute this negative a half now into the original function f of x and tell me what you get. I give you 3 minutes. So I've responded to one answer already. Wanting to see the others send me their responses, please. Very good to you, student.
I have answered, but I don't think it's correct.
Send me the answer, please. Send it in the chat. You can send it to me directly. And I've just projected my workout with the correct answer. Look at it for me, please.
(13/2).
Same thing as 6.5.
Oh, so this is the first derivative. I don't know what. I don't know why something don't look right.
No, I am substituting the value of x into the original function. So I'm using the second, I'm calculating the point of inflection. So in calculating the point of inflection, what I do is to find the second derivative of the function. And when I find the second derivative of the function, I set it equals to 0. So in this case, the second derivative was 12x plus 6. So I'm setting the second derivative equals to 0 right here. So I'm going to have 12x plus 6 equals 0. And then I'm going to transpose, so I get x equals to negative a half. It is that negative a half now that I'm substituting into the original function,
Yes, yes, that's what I'm referring to. I'm saying I never saw the original function. I only saw the derivative, the first and second derivatives.
And then we will do the sketch. That
looks like a minimum graph.
Sorry, can scroll up back for a minute, let me just take off the answer.
waiting on you, Dujon.
Sir?
I'm just saying, Dujon, I'm waiting on you.
Yes, sir, so finish. All right, sir.
All right. Okay. So we got our negative 2, 20 to be a local maximum. Maximum graphs turn downwards. So what I'm doing is plotting my graph. So if you look at, not plotting, I'm sketching my graph. So if you look here, I would have called this 2, negative 4, negative 6, negative 8, negative 10. So this is my negative 2, and I'm going all the way up to 20. This point here, it's a local maximum. So it turned downwards. And my 1,7, negative 7, that is, when I plot my 1, negative 7, that one there is going to be a local minimum. So it's going to turn upwards. And then it's going to be, I'm going to be connecting my 0, 0 is also a point that I must plot, which is my y-intercept. So I'm going to plot my 0, 0, and then I'm going to connect the points. My point of inflection, which is negative a half, comma 6.5, 2, 4, somewhere right here. I couldn't get that to show on this graph right here. So this is a sketch of the graph. That's a sketch of the graph.
So this overall graph, sir,
Mm-hmm.
even though it has both a maximum and minimum, it's still trending towards the minimum, right?
What do you mean?
No, because based on what you said, um minimum graph will have higher values basically, while a maximum graph will have lower values. And based on what I see on this graph, it has more higher values than it does lower values.
No. Don't look at it like that. Maximum, minimum, just train in the direction of the graph. So at this point, I'm testing this point. I'm investigating the nature of it. And the nature of that critical point, turning point, stationary point, is that when I investigate the nature using my second derivative, I'm getting a negative solution. The negative value of that graph is indicating that the graph at this point is a local maximum. It turns downwards. What I'm doing now is plotting, what I'm doing is sketching the graph of the cubic function. That's technically what I'm aiming to do, sketch a graph of the cubic function. But I'm doing it using my stationary points. And then this value here now, this value, my minimum value, is telling me that this is the lowest part of the graph for the turning point here. So the turning point for this minimum value occurs at this point where x is equals to 1, comma, -7. It's a local minimum. The local minimum value turns upwards. So don't look at it to say the local maximum value is lower or higher than the local minimum value. No, that's not the aim of doing this. The aim is to sketch the graph. But I need to investigate the nature of the points. And those points, the point down here tells me that it's a minimum, so it turns upwards. And the point here tells me that it's a maximum, so it turns downwards. And there are two other points that I have. The y-intercept right here, and my point of inflection that goes here. Are you with me?
Still trying to take it in, sir.
All right, so you weren't here earlier, so the class Crosswell is what we call a self-paced class. So like in a couple of minutes, I'm going to exit the class. But I am going to go through some stuff. So when I meet with you, I will go through a concept, explain the concept, and then leave you to figure it out. Some questions that I'm going to be giving you so you can concretize those concepts on your own. If there are difficulties, I will ask that you respond to the mail that I sent all of you as a link that we're going to be using, that you can say something to me. I can respond to you. If I believe that is something that is widespread, I can say, yo, you're the plan, give me a 15 minutes or give me a 20 minutes. So the self-pace is you working on your own, but I am there to guide you as you go along. Allow me to share something in the group with you, Crosswell. I don't know if you remember it, but I asked one of my trusted.
You're talking your calculus 2 group.
No, I just asked somebody a while ago to send me the link to my YouTube channel.
Oh, okay. You're
There
still
you go.
using Ecosoft, right?
Yes, I was promised to get access to the platform on Friday, yesterday, but the person who should have done the authentication or confirmation from one end to the next, I gather is unwell, and the deputy is also unwell. I think they have the terrible flu and they're out. I'm hoping that I really am hoping. I mean, I told my calculus school students
Um,
that they would have gotten it. I'm really hoping that by Monday I can hear something positive. Really and truly.
So I just went on YouTube a while ago and I saw a calculus one class from 2 days ago.
No, that's calculus 2. That will be calculus 2.
Sure, it specifically says pre-calculus semester 2. I see a calculus 2 class from 2 days ago.
Right.
As well.
That's what I just said. So I've uploaded my recordings. So what you're seeing, the recordings that I uploaded were pre-calculus, calculus 2, and chemistry and the environment. So for you to go and do some preparations, you'll have to go from semester 1, 2025, when I did calculus 1, the last outing for calculus 1. So just go through the thing and just look for calculus 1, semester 1, 2025. That will be the last outing of me teaching calculus 1.
I see.
And I would say to you again, those of you who have not yet done it, please to subscribe so at least you can
Yeah, see.
be notified when I upload videos.
Yeah, see them now.
All right. Are we okay otherwise though, guys? Because I'm going to be leaving you shortly. Are you okay? I'm gonna give you yes, yeah, you have to go through the stuff. Yeah, man. Yeah, you have to go through the stuff. All right. So this is what I'm gonna do. I'm gonna stop share for a moment. And while I stop share, I'm going to hold on a minute, please. While I stop share, I'm going to send. Hold on. All right. So what I'm gonna do is I'm gonna set you some questions. I'm gonna also send you this link of what it is that we did just now in the chat so that you can have a copy of the work done. And also, let me see if I can find a few questions to give you to do. In your, I really want you to, I really want you to block. I really want you to block a couple of hours on Saturday, guys. Whether or not I'm spending the whole time with you, that's not the problem. I want you to block a couple of hours so that you can focus on your calculus 1. When I leave, I don't expect you to be leaving with me. I'm expecting you to be working. Is that understood?
Yeah, I understand the vision.
Yes, sir.
Okay. Oh, good. All right. So I'm speaking to you and I'm copying some stuff to send off so that you can have some stuff. You guys were making notes. Copy. You guys were making notes. Please to use them to the top of the page. The questions, and I'm going to cut that. Okay, I'm going to cut that and then I'm going to paste it down here. And then also what I want you to do is go into the past papers. I want you to go into the past papers and find questions. Don't depend on me alone to find questions and give to you. I want you to get the past papers, find questions, work on those questions, and then you come back to me with them. Send me an email, photocopy it, I mean, a photocopy, screenshot it. That's, you know what I mean? Take a picture of it and come to me and send it off to me so I can look at it for you. So I can see that you're understanding. The self-paced can work. It worked last time I did it, and I'm expecting it to work this time around. Just be diligent with what it is that you're doing. And if you are diligent with what it is that you're doing, trust me, success must come. Success must come. All right, so I am sending, well, no, not sending yet. Yeah, so I want you to be able to work on your past papers. I want you to be able to work on your past papers and to start working on them from now. All right, so I think I have saved this. I'm giving you.
When is so based on the when is the midterms then?
We'll talk about that. As soon as we get some stuff in place, we'll talk about the midterm. So this. This we'll talk about midterm. Importantly is that you are ready and for what is to come. All right, so I'm going to send this off to you and trust that you guys are going to do some work for me. It's very important. Please don't let me feel like what I felt with the last group. Okay. And this thing is still giving me that same foolishness. I don't understand what is happening. Every time I save the document, it's from the internet it's happening to me. I save the document and the document's not coming up. And I know I save it. You know what? I think I know what the problem is now. I think there's something kind of phone. All right. See if you can download the document for me, please. I just sent something in the chat. See if you can download for me, please.
I'm downloading it right now.
Great. I'm happy that you saw it. Great. All right, guys. So I'm taking my leave. This is what it's going to be like. I will come in. I will give you some stuff that I want you to look at. Now, what is going to be your responsibility is not that, oh, class done early, so I can go watch TikTok or I can go, whatever the situation is. No, you're supposed to commit yourself. I'm supposed to be a 1 to 5 session. Commit yourself 1 to 5 to be doing calculus 1. You can take a break and put in some calculus 2 in it. I have no problem. But you cannot just sit down and not do the work, or else it's going to run away and leave you. Don't want that to happen to you.
I don't repeat calculus again. So
right. If you are finished with this and you want to find more questions, go to the past papers. Whichever past paper you're working on, you can email the past papers to the same link that was sent out to all of you today. so that when I go in there or anybody else go in there, we can just look at the links to see those past papers. And we can say, boy, sir, past paper 2025, question 2A. I can look at it, we can work it, and I can work and upload and send off to you. But guys, this must work. This must work, and I'm depending on you. All right? Remember, you have to use the YouTube channel. I won't necessarily send out these links, this one here, because it's not going to be a complete stuff. This is just me having conversations and intertwining with other stuff. I want you to be able to use the links from previous sessions. All right? I'm not hearing an amen.
Yes, sir.
All right, then cool. All the
Thank you,
best.
sir.
Take care, guys. All the
So
best.
one on this, sir. So, yeah, so the link I will use moving forward.
Yeah, I want to use this link. Yeah, so we can come in unless the institution gives me a different link, because as I say, I need to email something to Miss Campbell. If she decides now that they want to give me a link every Saturday, that's fine. But for now, we're gonna keep on the little link here. Where we just go and use it.
All right, sir. Respect.
Big up yourself.
Oh, it's Q. Minus 2x minus 7.
Okay. Ibara.
My apologies. So you may call.